So today we will be starting with differential calculus, and this formula is called the first principle of derivative. So to get to that specific formula, first we have to learn what functions are, and after understanding functions we will move on to understanding the concept of slope, and after understanding the concept of slope we will move on to graph plotting, and then we will do limits, and then finally we will understand the first principle of derivative. So this is actually part of differential calculus. So if we look at the etymology, calculus is the Latin word for stones. So why only stones? Basically, ancient Romans used to calculate numerical values by using stones. So calculus is basically the Latin word for stones. And why do we even use calculus? Basically, calculus is branch of mathematics dealing with the study of rate, growth or motion. So this is the definition of calculus. So calculus is the branch of mathematics which actually helped us to understand or study the rate of change of something, let's say a function, or growth of it. And differential calculus is the part of calculus is basically of two parts, integral and differential. So differential calculus is, let's say we get a graph where there is a curve. So to break down this curve, we use differential calculus. So basically we need to break down the curve into smaller straight lines to understand the slope of the curve. So we can actually analyze the rate of growth for the graph of the function. So we will get back to this specific part after understanding limits and graph plotting. So starting from functions, let's say two variables x and y such that the value of y is dependent on the value of x. So this is what a function is, and the general notation for function is function of x, and function of x can also be denoted by y as said earlier. So we can basically write function of x is equal to y, where x is the input value and y we get as the output value. So as x varies, the value of y will also vary. So let's do it with an example. Let's take the formula for volume of a sphere. which is 4 by 3 pi r cube. And also a function may consist of variables and constants. So in this specific formula, V is basically the volume of the sphere. Four by 3 pi is actually the constant for this specific formula, and here r is the variable. So as we know, this is a constant value. This will not change whatever we plug in the value of x of r, because in this case the two variables are v, which is denoting the volume, and r, which is radius of the sphere. So in this case we can say v is the function of r, where r is the radius of the sphere and v is the volume of the sphere. We can also do this with more examples. Let's say there exists a function f of x is equal to 3x cube plus 4x minus 11. So what would be the value for this particular function at x is equal to, let's say, 2? So as we said, this is the input value, and this value is going to change, and this is a constant. That means this whole is y, and as x square and x, basically x is a variable, that means this value is going to change for any value of x which you plug in. That means at x is equal to 2, and this is how we denote. If we are using, if we are replacing x with a number, we write function of 2 or function of any number which you are using, and then we write which is 3 times 4 plus 8 minus 11, which would be 9. Hence we can say that so this is actually the general notation for our function. We can also use other variables, let's say function of z or function of a, but this is actually the most used notation for a function. So let's say we take another function x squared plus 1. So we can replace the value of x, function of 1, which would be 1 square plus 1. Therefore function at 1 is equal to 2. That means when x is equal to 1, y is equal to 2. And similarly, we can replace x as another variable. We can also do that. Would be a square plus 1. That means when x is equal to a, y is equal to a square plus 1. We can also do function of a plus h. This would be equal to a plus h whole square plus 1, which is a square plus 2ah plus h square plus 1. So basically, as we can see that this is the y value, and this is x, and the y value is basically dependent on x. That means we can do a proper graph plotting for various functions which we make. So before moving on, function of theta. So this we use mostly in trigonometric functions where the value of the function is dependent on the value of the theta. For example, sine theta. Here sine is a function and the value is dependent on theta, and this can also be denoted as phi x sine x. Therefore phi x and function of theta commonly used for functions which are dependent on angles. So you can note this down. So let me just give you a function 2x. Means we can also write as y is equal to 2x. So if you actually look careful at the equation, we can manipulate the equation and we can make x as a function of y. We can do dividing both sides by 2. We get x is equal to y by 2. So here you can see that the value of x is now dependent on the value of y. And if you do the graph plotting for this specific function in which x is dependent on the value of y, it would be the same as the graph of this function where y is equal to 2x. So these are called inverse functions. But generally this form is much more preferred than this one because this is how we conventionally use. So in case of inverse functions, the graph would always be the same. Therefore, the two functions are actually the same. Just the notation is different. In case of inverse functions. So you can pause the video and you can write this down. So let's take the general form of a function again. So if you actually see at the function, when x varies, so will the value of the function. That means if x is changing, y would also change. And you can denote the change in x by delta x, or you can highlight this point. And this actually tells us change in x. And delta x is not delta into x. So if you are actually writing this at this form, this is totally wrong. We just simply denote it as delta x or we can use a triangle, and this is also called delta. And this is small d